Hello, everyone. Welcome to the Revit MEP course. My name is Derek, and I'll be guiding you through this comprehensive training program. This course is designed to cover the full spectrum of Revit fundamentals, from interface navigation and modeling basics to advanced systems, collaboration workflows, and family editing. Whether you're just starting out or looking to refine your skills, this course will equip you with practical, industry aligned knowledge. A quick introduction about myself: I'm a consulting mechanical engineer with multiple academic qualifications, including a national diploma, bachelor's degree, honors degree in mechanical engineering, and I'm currently pursuing a Master of Engineering degree in fire engineering. Professionally, I'm registered with Engineering Council of South Africa as a professional engineering technician. I'm also registered with Green Building Council of South Africa as Green Star accredited professional, and I'm a proud member of South African Institution of Mechanical Engineers. Last but not least, I'm a certified BIM practitioner with Opera in line with ISO 19650 through Opera Academy. You can reach me anytime via email at info@226k-engineers.co.za or visit our website at www.226k-engineers.co.za for more resources and updates. Let's dive into the course and explore how Revit empowers MEP professionals to design smarter, collaborate better, and deliver with precision. Module 00, Revit in a nutshell. Let's begin our journey into Revit with Module 00, which sets the foundation for everything that follows. We start by asking, what is Revit MEP? Revit is more than just a drafting tool, it's a building information modeling platform that integrates mechanical, electrical, and plumbing systems into a unified digital environment. Next, we explore its core capabilities: parametric modeling, system coordination, automated documentation, and collaborative workflows. These features make Revit a powerful tool for engineers and designers working on complex building projects. We then look at why Revit matters, not just for design efficiency, but for reducing errors, improving communication, and aligning with global BIM standards. To ground this in reality, I'll walk you through an example in practice showing how Revit supports multidisciplinary design in a real world project. Finally, we'll do a quick comparison between Revit and traditional computer aided drafting workflows. This will highlight how Revit's data rich modeling and automatic updates give it a major edge over conventional drafting tools. This module is all about understanding the why behind Revit. So you're not just learning software, you're embracing a smarter way to design and deliver. Module 01, introducing Revit as a BIM tool. In this module, we lay the conceptual foundation for using Revit effectively by understanding its role within the broader BIM ecosystem. We begin with the question, what is BIM and what does it mean? BIM, or Building Information Modeling, is a process that integrates geometry, data, and collaboration into a single digital model. It's not just about 3D, it's about intelligent design and lifecycle management. Next, we explore the benefits of BIM, from improved coordination and reduced errors to enhanced visualization and faster decision making. BIM empowers teams to work smarter, not harder. We then ask, what will BIM deliver? The answer includes better project outcomes, streamlined workflows, and more predictable costs and timelines. We'll also look at industry drivers, the forces pushing BIM adoption globally. These include regulatory mandates, client expectations, and the need for sustainable, data driven design. Then we introduce the levels of BIM, which define the maturity of BIM implementation, from basic 3D modeling to full integration with cost, time, and operational data. Finally, we discuss the implications of BIM on your team structure, workflows, fees, deliverables, contracts, and even insurance. BIM isn't just a tool, it's a shift in how we design, collaborate, and deliver value. Module 02 UI Tour, Project Navigation and View Creation. In this module, we get hands-on with the Revit interface and learn how to navigate the project environment with confidence. We begin with a menu and screen layout overview, helping you understand where tools live and how to access key functions efficiently. Then we dive into extracting views, including plans, sections, and elevations, which are essential for documentation and coordination. We also explore displaced views, callouts, and drafting views, which allow us to isolate and detail specific areas of the model. Next, we move into 3D isometrics, perspectives, and walkthroughs, giving us the ability to visualize the project in immersive formats and communicate design intent clearly. We'll cover the placement and properties of grids, levels, and dimensions, which form the backbone of spatial organization and measurement in Revit. Finally, we introduce basic Revit elements, setting the stage for modeling components and systems in later modules. The exercise for this module focuses on creating levels and grids and using dimensions and scope boxes to define and control your project views. This module is all about orientation, making sure you're comfortable navigating the Revit environment and extracting the views you need to move forward. Module 03, Element Selection and Manipulation. In this module, we focus on how to interact with elements inside the Revit environment, selecting, modifying, and understanding their properties. We begin by exploring object selection methods. Revit offers multiple ways to select elements, whether individually, by filter, or using selection boxes. Knowing how to control selection is key to working efficiently. Next, we look at element properties and manipulation. Every object in Revit has parameters that define its behavior and appearance. We'll learn how to access and adjust these properties to suit our design intent. We then differentiate between instance and type parameters. Instance parameters affect individual elements, while type parameters apply to all elements of a given family type. Understanding this distinction is crucial for consistency and control. We'll also cover modify tools, including trim, offset, align, and more. These are your core editing commands. Alongside that, we'll introduce nodes and snaps, which help you precisely position and connect elements. The exercise for this module will give you hands-on practice with basic editing tools, trimming, offsetting, aligning, so you can start shaping your model with precision. This module is all about control, learning how to select and manipulate elements confidently so your modeling becomes intuitive and accurate. Module 04, Visibility Control and Categorization. In this module, we explore how to control what you see and how you see it within your Revit project. We begin with project-wide settings, which define visibility rules across the entire model. These are your global controls that affect all views unless overridden. Next, we look at view-specific overrides. These allow you to tailor visibility for individual views. For example, hiding certain categories in a floor plan, but showing them in a section. Then we move into element-specific overrides, which let you control the appearance of individual components. You can adjust line weights, colors, or patterns for selected elements without affecting others. We also cover individual line overrides, giving you granular control over how specific edges or boundaries are displayed, ideal for detailing and presentation. The exercise for this module focuses on modifying element visibility using these layered controls. You'll learn how to combine overrides effectively to achieve clarity and precision in your documentation. This module is all about visual communication, making sure your model tells the right story to the right audience, whether it's contractor, client, or consultant. Module 05, Model Development Methodology. In this module, we take a step back from tools and commands to understand how a Revit model actually develops. Not just technically, but conceptually. We begin by asking, is BIM just about 3D? The answer is no. BIM is about integrating data, collaboration, and life cycle thinking into the design process. The 3D model is just the shell. The real power lies in the information it carries. Next, we explore the information timeline and overload. As projects evolve, data accumulates rapidly. We'll look at how to manage that flow, what to model early, what to defer, and how to avoid drowning in unnecessary detail. Then we examine project development from a base template. Revit projects often start from a standardized template that includes preloaded families, views, and settings. This ensures consistency and saves time across multiple projects. We also discuss the complexity of components. Not all elements are created equal. Some are simple, others are deeply parametric. We'll learn how to balance detail with performance and avoid overmodeling. Finally, we look at controlling graphical display. This includes view templates, filters, and visual styles that help communicate design intent clearly and professionally. This module is about strategy, understanding how to build a model that's not just functional, but scalable, maintainable, and aligned with project goals. Module 6, establishing a project. In this module, we focus on setting up a Revit project correctly from the start, laying the groundwork for accurate modeling and smooth collaboration. We begin with project units, understanding how Revit handles measurements across disciplines like HVAC, electrical, and plumbing. Getting these units right ensures consistency throughout the model. Next, we configure MEP settings, symbols, and schematic design. These settings define how systems behave and appear, and they're critical for aligning with engineering standards. We then move into project commencement and collaboration. This includes setting up shared parameters, defining roles, and preparing the model for multi-user access. A key part of this module is linking AutoCAD and Revit architecture. We'll learn how to bring in external references and coordinate with architectural models using Revit's linking tools. We also cover coordination review, which helps detect clashes and ensure that all disciplines are aligned before moving forward. The exercise for this module involves linking a Revit architecture model and using copy or monitor tools, a practical way to synchronize elements and maintain control over shared components. This module is all about precision and preparation, making sure your project starts on solid ground and is ready for collaborative success. A Module 7, Introduction to Building Elements. In this module, we begin working with the core architectural and structural components that make up a building model in Revit. We start by defining the basic building elements: walls, floors, roofs, and ceilings, and understanding how each behaves within the modeling environment. Then we look at sketching rules and slab wall relationships, which help us control how slabs interact with supporting walls and how geometry is constrained. We'll also explore slab slopes, roof design, and ceiling definition, giving us the ability to model realistic building envelopes and interior finishes. Next, we introduce system family editing, which allows us to customize built-in Revit elements like walls and floors to meet specific design requirements. We then move into column and beam placement, essential for structural coordination and load-bearing design. The exercise for this module focuses on element placement techniques and the development of a composite wall, combining multiple layers and materials into a single intelligent assembly. This module is all about mastering the building blocks, learning how to place, shape, and customize the elements that form the backbone of your Revit model. Module 08, equipment, fixtures and fittings. In this module, we shift our focus to the components that populate our spaces, the equipment, fixtures and fittings that bring functionality to the model. We begin by clarifying family terminology. In Revit, families are the building blocks of components, from air terminals to sanitary fixtures. Understanding how they're structured helps us manage and customize them effectively. Next, we cover component placement. This includes hosted elements like sinks, lights, and diffusers, and how they interact with architectural geometry. We then explore level selection, including FFL, finished floor level, SSL, structural slab level, floor soft feed, and ceiling soft feed. These levels guide placement accuracy and system coordination. We'll also walk through the MEP workflow, showing how mechanical, electrical, and plumbing elements are placed, connected, and scheduled within a coordinated model. The exercise for this module focuses on hosted elements, visibility controls, and multi-story design, giving you practical experience in placing and managing components across different levels and views. This module is all about precision and context, placing the right elements in the right way with full awareness of how they behave and interact within the model. Module 9, Introducing Systems. In this module, we begin integrating intelligence into our model by introducing Revit's system-based design approach. We start with project profile setup, which defines the discipline units and system behavior for your MEP environment. This setup ensures that your model responds correctly to the types of systems you'll be working with. Next, we explore the main systems: mechanical, electrical, and piping. Each of these has its own logic, connectors, and flow paths. And Revit allows us to model them with precision and coordination. We then dive into the system browser, which gives us a structured view of all active systems in the project. We'll also look at connectors, the key to linking components, and how air systems are generated and managed. The exercise for this module focuses on creating a system-generated air supply layout. This will give you hands-on experience in defining flow paths, connecting equipment, and verifying system behavior. This module is all about connectivity, understanding how Revit treats systems not just as geometry, but as intelligent networks that drive performance and coordination. Module 10, Basic Schedules and Legends. In this module, we shift from modeling to interrogation, learning how to extract meaningful data from our Revit model. We begin with tabular model interrogation, which allows us to query the model and generate structured tables that reflect real-time data. This is where Revit's intelligence really shines. Next, we explore scheduling components, from doors and equipment to ducts and fixtures. These schedules are dynamic, meaning any change in the model updates the schedule automatically. We then look at style schedules, which help us format and present data clearly. Whether it's for internal coordination or client reporting, style matters. We also introduce legends, which are used to visually explain symbols, tags, and system types. Legends help standardize communication across drawings and disciplines. The exercise for this module involves creating a schedule and a legend, giving you a hands-on experience in extracting and presenting model data. This module is all about clarity and control, turning your model into a source of truth that supports documentation, decision-making, and collaboration. Module 11, Geometry Formation and In-Place Families. In this module, we explore how to create custom geometry in Revit, both for modeling and for building intelligent components. We begin with the 5 core solid and void forms used in Revit's family editors: extrusion part C, adjacent path shape, a basic shape pulled along a straight path; blend, a transition between two profiles, press revolve, a profile rotated around an axis; sweep, a profile pushed along a path; swept blend, a hybrid of sweep and blend. Transitioning between profiles along a path, these forms are the foundation for creating custom components, especially when standard families don't meet your design needs. We also introduce in-place families, which allow you to create geometry directly within the project environment, ideal for one-off elements that don't need to be reused. The exercise for this module involves creating each of these forms, giving you hands-on experience with Revit's modeling tools, and helping you understand how geometry is structured and manipulated. This module is all about creativity and control, learning how to shape geometry with precision and purpose, whether you're designing a custom duct fitting or a sculptural architectural element. Module 12, mechanical systems. In this module, we focus on the mechanical backbone of the building, the systems that move air, regulate temperature, and support occupant comfort. We begin with mechanical settings, which define how Revit handles ductwork, pipework, and system behavior. These settings are foundational for accurate modeling and analysis. Next, we explore duct types and fittings, understanding how different shapes, sizes, and connection types affect flow and coordination. We then look at duct and plumbing systems, including how they're defined, connected, and visualized within the model. Revit allows us to build intelligent networks that respond to design changes. We also cover insulating and lining ductwork, which adds realism and performance data to your systems, essential for energy modeling and compliance. Then we introduce plant and equipment, from air handling units to chillers, and how they're placed, connected, and scheduled. Finally, we dive into mechanical pipework, flanges, and fittings, giving you the tools to model complex piping layouts with precision. The exercise for this module involves completing and checking a ventilation system. It's a practical task that reinforces everything we've covered. This module is all about systems thinking and designing mechanical networks that are coordinated, efficient, and ready for real-world implementation. Module 13, Electrical Systems and Circuits. In this module, we explore how Revit handles electrical design, from component placement to circuit logic. We begin with equipment, devices, and fixtures. These include lighting fixtures, switches, panels, and power outlets, all of which are modeled as intelligent families with electrical connectors. Next, we look at wiring, cable tray, and conduit modeling. Revit allows us to route electrical paths with precision, ensuring coordination with architectural and structural elements. We then dive into circuits and switch systems. You'll learn how to assign devices to circuits, define panel connections, and simulate switching behavior, all within a coordinated model. The exercise for this module focuses on using electrical service type filters, a powerful tool for organizing views, isolating systems, and improving documentation clarity. This module is all about electrical intelligence, designing systems that are not only spatially accurate, but also electrically functional and ready for real-world implementation. Module 14, Plumbing Systems. In this module, we turn our attention to plumbing, the systems that manage water supply, drainage, and sanitation within the built environment. We begin with plumbing settings, which define how Revit handles pipe types, flow calculations, and system behavior. These settings ensure that your model reflects real-world performance. Next, we explore plumbing fixtures, sinks, toilets, basins, and other components that connect to plumbing systems. These are hosted elements with predefined connectors and flow characteristics. We then look at plumbing and sanitary systems, including how to define system types, connect fixtures, and manage flow direction and pipe sizing. We also cover domestic, hot, and cold water systems, showing how to model supply networks that meet building requirements and support fixture demand. The system browser helps us organize and review active plumbing systems, making it easier to manage complexity and ensure coordination. The exercise for this module involves creating both sanitary and plumbing systems and applying system type filters to control visibility and documentation. This module is all about fluid control, designing systems that are hygienic, efficient, and fully integrated into the building's infrastructure. Module 15, Spaces, Zones, Areas, and Volumes. In this module, we explore how Revit handles spatial intelligence, the ability to define, analyze, and visualize the volumes and areas within a building. We begin by understanding the difference between spaces, zones, areas, and volumes. Spaces are room-based elements used for analysis and scheduling. Zones group spaces for system control, while areas are used for planning and quantification. Volumes help us understand air distribution and thermal behavior. Next, we look at bounding elements, tags, and schedules. These define how spaces are enclosed, labeled, and reported, essential for both design and documentation. We then dive into area and volume computation, learning how Revit calculates these values and how to control the accuracy and scope of those calculations. We also explore how to use space data outside Revit, exporting information for energy modeling, facility management, or compliance reporting. Then we introduce color schemes and legends, which help visualize spatial data like occupancy, usage, or system zones, making your model more communicative and insightful. The exercise for this module involves creating and manipulating spaces, giving you hands on experience in defining, tagging, and analyzing spatial elements. This module is all about spatial awareness, using Revit not just to draw buildings, but to understand how they function, breathe, and serve their occupants. Module 16, 2D drafting and annotation. In this module, we focus on the tools that bring clarity and detail to your drawings, the annotations and 2D elements that support construction documentation. We begin with annotation tools and component categories. These include dimensions, tags, and symbols that help communicate design, intent, and technical requirements. Next, we explore detailed component libraries, preloaded elements like insulation, fasteners, and profiles that can be dropped into views to enhance clarity. We then look at repeating details, which allow us to apply patterns or assemblies across multiple instances, ideal for things like wall ties or ceiling grids. We also cover lines and arcs, which are used for sketching, diagramming, and enhancing detailed views. These are simple but powerful tools for 2D expression. Then we move into text, tags, and keynotes, essential for labeling components, referencing specifications, and guiding contractors on site. The exercise for this module involves generating and annotating a construction detail, giving you hands-on experience in combining 2D drafting with intelligent annotation. This module is all about communication, using Revit's 2D tools to make your drawings clear, compliant, and construction ready. Module 17, Sheet Compilation and Publication. In this module, we bring everything together into a professional set of deliverables, organizing views, compiling sheets, and preparing documents for publication. We begin with project browser organization, focusing on how to structure your views into work in progress, WIP, and publish categories. This helps maintain clarity and control as your project evolves. Next, we cover creating and populating sheets. You'll learn how to place views, adjust title blocks, and manage sheet parameters to produce clean, consistent documentation. We then explore working with schedules, integrating tabular data into sheets to support coordination, quantity takeoffs, and compliance. Finally, we look at publishing and document management. This includes exporting to PDF, managing revisions, and preparing your model for submission or construction. This module is all about presentation, transforming your technical model into a clear professional set of documents that communicate design intent and meet project requirements. Module 18, Basic Subdivision and Collaboration. In this module, we focus on how large-scale Revit projects are structured and managed across teams, ensuring clarity, control, and collaboration. We begin with the BIM strategy document introduction, which outlines the project's modeling standards, naming conventions, and collaboration protocols. This document is the foundation for consistent team execution. Next, we look at model management, how to structure files, manage links, and maintain performance as the project grows in complexity. We then explore project team collaboration techniques, including shared models, cloud work sharing, and communication workflows that keep everyone aligned. We also cover transmittal and model issue protocols, which define how models are exchanged, reviewed, and updated, critical for maintaining version control and accountability. Then we introduce large model subdivision basics using tools like work sets and linked models to break down complex projects into manageable parts. The exercise for this module involves using work sets and task allocation, giving you hands-on experience in dividing responsibilities and managing access across disciplines. This module is all about teamwork, building models that are not only technically sound, but also structured for collaboration, scalability, and long-term success. Module 19, Principles of Family Editing. In this module, we focus on the art and science of creating custom Revit families, components that are intelligent, parametric, and reusable. We begin with the basic process of family creation. This includes choosing the right template, defining reference planes, and setting up parameters that drive geometry and behavior. Then we walk through the 10 stages for trouble-free family creation. These stages guide you from conceptual setup to final testing, helping you avoid common pitfalls like over-constraining geometry or mislabeling parameters. The exercise for this module involves defining a fully parametric mechanical component, giving you hands-on experience in building a family that responds to input, adapts to context, and integrates seamlessly into your project. This module is all about precision and foresight, designing families that are not just functional, but robust, scalable, and aligned with your modeling standards. We've reached the final module, a moment to reflect on what we've accomplished and look ahead to what's next. Upon completion of the full course, you'll master the Revit interface and modeling tools, building confidence in navigating the environment and creating intelligent geometry. You'll be able to develop mechanical, electrical, and plumbing systems, integrating real-world engineering logic into your models. You'll be able to create schedules, legends, and annotated sheets, transforming raw data into clear professional documentation. You'll be able to understand collaboration and BIM strategies, learn how to manage large projects, coordinate across teams, and maintain model integrity. You'll gain skills in family creation and editing, enabling you to build custom components that respond to design needs and project standards. And now, the next step is yours. Apply these skills in real-world projects, contribute to multidisciplinary teams, or pursue certification to formalize your expertise. This course will equip you with the tools, mindset, and methodology to thrive in a BIM-driven environment. Keep building, keep refining, and keep pushing the boundaries of what you can model. The final word, we've journeyed through the full spectrum of Revit MEP, from elemental placement to intelligent systems, from annotation to collaboration, and from geometry to documentation. But mastery isn't just about knowing the tools, it's about applying them with purpose, precision, and confidence. Like the tiger, focused, fierce, and unapologetically present, your skill set now has bite. You're not just navigating Revit, you're commanding it. So as you step into your next project, your next challenge, your next opportunity, remember you've earned your stripes. Now go leave your mark. End of presentation. Thank you for joining this journey through Revit MEP. Whether you're just starting out or refining your expertise, Your commitment to learning is what drives real progress. If you found this valuable, like and subscribe to support the channel. It helps us keep creating content that empowers professionals like you. Comment below with your thoughts, questions, or feedback. I'd love to hear how you're applying these skills. Follow the link to download your study material and continue building your mastery beyond the screen. And most importantly, thank you. Your time, focus, and curiosity are what make this work meaningful. Let's keep building, let's keep learning, and let's keep raising the standard